Shrink continued. 2-6 continued. 2-6B. Yes. Okay. Does everybody have their little cheat sheet?
Yes.
You will definitely need that, huh? We'll see. Right now, just. All right. Pass that back to Amani, please. All right. Listen, when these are gone, these are gone. Don't lose them. And we'll reference them in multiple chapters too, so keep up with them. I had some people last semester take them to the front of their binder, so they always had them. So make sure you do them. Put them someplace where you won't lose them. All right, shrinks and stretches. We talked about the shifts yesterday. We talked about the reflections yesterday. But sometimes the graphs get wider or skinnier. Okay. So before I show you how to do it and what makes them, let me show you what they look like.
I already lost mine. We need to
think about other words you might see for this are dilation. Think about when you go to the eye doctor and you get your eyes dilated, your pupils get big, right?
Yes.
Compressions. Smaller. So dilation's bigger, compression's smaller. Just synonyms here that you'll see. I don't even know what your book uses most of the time. I think it uses both. Dilation and compression. But it also uses stretches. So just know that they all kind of what we're looking at. We're really going to look at the factor is going to tell us whether it gets bigger or smaller. Now, think about, and I think it's easiest to see with a parabola. So let me just start with a parabola. I have this parabola. Okay, let's call this the parent graph. 0, 0, 1, 1. I don't know what my board is doing. All right, so just our basic parent graph. I can do these vertically or horizontally. So let's look at them vertically first. Vertically. Imagine my axes are rubber bands. Okay? And I could stretch them or smush them. If I vertically stretched my axis, so my vertical axis is which one? The Y, right? If that was a rubber band and I stretched that graph out, what would happen to the picture? The parabola is going to get skinnier, right? It's going to shrink in actually. So this is skinnier. When you really understand what it's doing, it makes this a little bit easier. But if I vertically shrink, so in other words, I take that and I go smush it in, what happens to my parabola?
It gets fat.
It gets wider. Now let's talk about horizontally. Now my x-axis is a rubber band. Okay? If I stretch out the x-axis, what happens to the graph? It gets wider. And if I smush it in, what happens? Skinnier. So do we see that they're opposites? A vertical stretch could also be described as a horizontal shrink, and a vertical shrink could also be described as a horizontal stretch. Does that make sense to you? As to what? A vertical, well, you have to be able to know that they're the same thing.
They're basically opposites, like the vertical stretches.
They are.
Yeah.
A vertical stretch can also be described by a horizontal shrink, because stretching this axis out is the same thing as smushing this axis in, right? They have the same impact on the graph. And then a vertical shrink could also be described as a horizontal stretch. Okay? Now here's where it gets confusing, is when we have to start talking about the equation. On your sheet, the last two rows, okay? Vertically, we'll talk about vertically first. Let me go back. Okay. All right. Vertically, if I take a value, any value, I'm going to call it A because that's what I called it on your chart here, and I multiply in front of the function, okay? This is the same thing when I start talking about in front of the function like we did with the reflections, okay? It's just a number stuck out front. That's going to indicate a vertical shrink or stretch. We'll talk about that. Horizontally is whenever I only do it to the x. So every x in the equation has some number just in front of it versus it just being in front of the entire equation, okay? Yes.
Could you do f of, could you like switch the places of x to a?
You could,
Like, will it make a difference?
of which one now? A and x?
Yeah, like if like x is here and a is not
You could, but generally, I mean, if you have an equation, you're going to have like 1/2 x. So that's why I wrote it like that. Because I started to do the same thing, but. All right.
Why does it show on the right side x over a for the coordinate?
Because that's how you have to find it. We'll get there. Hold on. All right, so I'm on second column now, okay? Vertically. And this is where it starts getting confusing. We're looking at the absolute value of A because A being positive or negative has to do with reflection. It's not going to have to do with shrink or stretch, okay? If A is bigger than 1, the absolute value of A, okay? If it's bigger than 1, it's a stretch vertically. But if it's less than 1, it's a vertical shrink. How is the absolute value of A going to be less than 1? Can't be negative because it's absolute value. Close.
0, yeah.
Between 0 and 1. What is between 0 and 1? Fractions less than 1. Okay? So we're talking like 1/2, 2/3, 1/4, 3/4. Anything less than 1 is going to be a vertical shrink.
Wait,
Okay?
how can it not be negative? Like that one, I remember I had that one graph went down for absolute value.
That tells us, so if you had like y equals negative 1/2 x squared, right? The 1/2 is your A. This has to do with reflection. It has nothing to do with your shrink or stretch.
Wait, so
It still impacts the graph, but it impacts it in a different way. It doesn't impact it as far as the stretch or shrink.
I thought I had an absolute value question. It was like absolute value of or negative x and it went down. Or sorry, negative absolute value of x.
That would go down.
And it went down.
That's correct. Because that's a reflection over x.
So that was just a reflection.
Correct.
so these would be the same for horizontally but flipped.
But opposite. So for horizontally, the absolute value of A bigger than 1 is a horizontal shrink. And the absolute value of A less than 1 is a horizontal stretch. And I'm just getting this straight from your sheet here.
That
Okay?
makes sense because it was the opposite in the beginning. Like,
Right. Everything with X on these is opposite of what you'd think it would be. Okay? It just is. So let me show you a couple examples. You tell me, I'm going to give you an equation. You tell me horizontal or vertical, shrink or stretch. Is the graph getting wider or skinnier? Okay? You'll stay with me on this, all right? And then I'm going to talk about how we find the points. And that's that last column there.
We're going to do 7 day 2.
We're going to see.
That would be.
First of all, what's the parent graph
It's
here?
vertical. Oh, x parabola.
It's just a parabola, right? X squared. 0, 0, 1, 1, negative 1, 1.
It's a vertical stretch.
Okay, so what is your A? And is your A
Four.
hooked to the front of the equation or only to X?
The front.
The front. Do we see why?
There's no
Now
parentheses.
remember, technically, I could make this also horizontal and it would change a little bit, right?
Yeah.
Okay, I could rewrite it. So don't start getting things flipped around in your head. Take it for what it is. Yeah.
Why is it a vertical?
It's
All right.
in front.
So it's in front here. There's no parentheses. So this looks like this.
What?
If f of x is x squared,
Okay.
then this is a times f of x, right? It's in front of the whole equation. It is different than this.
That'd be the
This
is horizontal.
would be horizontal. This one is vertical.
So basically, it's like using-
Does that make sense? Do you see the difference, Luke, in this? Oh my.
I do see the difference.
Yes, there's clearly a difference there. This and this.
Yeah, because
It's got the parentheses.
It's hooked
The
onto
parentheses
X.
tell me horizontal, the no parentheses just out front tells me vertical.
But if it was parentheses and the 4 was on the outside of the parentheses, it'd be the vertical.
Right. All right.
And it went on.
And that's lovely.
If it's inside.
Yes,
yeah.
but I'm hesitant to say that all the time because I could technically rewrite this. You could make an argument for both
We
ways
can't
this way.
It went off like that.
All right, give it just a second. So once we determine vertical or horizontal, we find our A. Our A is 4. I know it's vertical, it's in front, so I look at vertical. Absolute value of A is bigger than 1, which tells me it's a vertical what?
Stretch. So it gets
Stretch.
Skinny.
So now if I think about that vertical axis just stretching out, this is going to be a parabola that is skinnier than the parent. So if this is the parent, then this one is going to be somewhere inside skinnier.
Yeah, it would be.
All the, you would take, okay, so let me tell you what you would do. Look at the third column there. Okay. Do you see how it says every xy becomes x a times y? What is a?
4.
4. So if this was 1, 1,
Then it will become
my new point would be
1, 4.
1, 4.
That's where it's
Okay,
see.
I see. So you're taking the old point and you're putting 4 in with.
Multiplying
by
the y by a.
Okay. Wait, so basically, if there were, so parentheses, it's horizontal without parentheses. Like, depending on like what.
Depending on the parent function, yeah. Amani, do you have a question?
So it's a vertical stretch because for x is the absolute value of that is.
Right. Okay. You may be asked for a stretch factor. The stretch factor is, guess what?
Your A.
Your A.
Yeah.
It's 4. Okay. Now horizontally, everything's going to be different. It's going to be reversed.
It's a
Remember that.
division.
But well, right. Okay. But right now, I could say this function is a vertical stretch with a factor of 4.
Vertical stretch
Vertical stretch,
with a factor of 4.
factor of
equals A.
4. Well, it does, but whenever you're horizontal, it's 1 over A.
Weird.
So vertically, yes.
Okay. Can you do one with the absolute value of x?
Yes. All right, look at this one.
Okay.
And don't blurt it out just yet. My first question to you is this a vertical or a horizontal? Why?
Because it's multiplied together in the x.
It's
And
with the
value.
x. That's telling me right off the bat it's horizontal. What would this look like if it was vertical?
Like 3 on the outside.
The 3 would be in front of that absolute value sign. Do you see the difference?
So the absolute
Correct.
So if the 3 was in front of the absolute value, it would be this.
Yes. This is horizontal. So now I'm looking at the horizontal line, right?
Uh-huh.
Is the absolute, what is A?
3.
3. Okay. 3 is bigger than 1, right?
Yeah.
Okay. So it is a horizontal shrink
Or compression. Okay, I'll say.
or compression, either one. Oh, I did mix those words up on. No, I put them both.
Uh-huh.
But yeah, a horizontal shrink or a compression. Compression's probably a little bit better word, but I understand shrink better. All right, so it's a horizontal shrink, right? If it is a horizontal shrink, is the graph getting bigger or smaller?
Skinny.
Or wider or skinnier?
Skinnier.
Horizontal.
Wider.
Skinnier.
Skinny.
Horizontally, take the horizontal axis and smush it in.
Right.
And what's the graph gonna do? It's gonna go in, right? It's gonna go from this to this.
Yeah.
All right. This time, it's a shrink. What do you think my factor is?
3. Oh, no, it'd be, the x over 2.
1/3. Okay, everything with x's is opposite. This, since it's a shrink, they're shrinking down. I need to make sure that my factor there reflects that, right?
Where did you get the 1 from? I thought the 1 was just to the x, and we don't have a point yet.
The 1 would go under the 3. You could do that.
No, it wasn't. The x is on top.
What are y'all talking about right
On
now?
the sheet, like in the 3rd column, it says x over a.
Right,
But we
so
don't
what
have an
it's
X.
saying, it's saying take every point on the parent graph, divide the x by a, or multiply it by 1 over a, same thing, and keep y the same.
I was wondering how you got the 1 over 3 because we don't have an x coordinate yet.
And that's how you find the points.
That's just how you do the factor, you put it over 1.
That's how you find those points too.
So, yes, so let me put the parent graph on here, 0, 0.
So if this was all
Or the
yes.
fraction?
Yes.
Okay.
Lots of these are gonna be fractions. Here's the parent.
Yeah.
Right? And this is what I was telling you I wanted to see on your homework last night because I really wanted you to see how it was moving from the parent. All right, so now take every point, and let me just put the coordinates here so you see 1, 1.
So your
Negative
factor
1,
always
1.
split.
Yes, on horizontal, only horizontal, okay? That's why this little slip of paper is going to be your best friend
So how
as
are
you
you
go
gonna
through
get that?
these.
That'd be 1/3.
All right, so I have these points, right? Instead of 0, 0, well, actually, it's still going to be 0, 0, so we're good there. Instead of 1, 1, y is going to stay the same, but I'm going to divide x by my a value. So this point is going to become 1/3 1. 1/3 1.
But if it was 2, if it was 2, 2, it would become 2/3 2?
Yes.
Okay.
This one will become negative 1/3 1. Did it do what we thought it would do?
Yes.
Yes, it shrunk in. It got skinnier. Does that make sense?
Yep.
I've tried to go super, super slow.
No, you did.
All right, let's do another.
super horizontal, you're always changing the, x.
Yes. Okay.
Not yet.
And then vertical, always changing that.
Let me ask you this question and see. Go back to the example we did before this one. I can't remember if I said this or not. I didn't. How could I come up with the same exact equation but doing it as a horizontal shrink instead?
You would just, you would,
It'd be 1 over 4. I mean, not.
Write the equation.
you have to do 1/4. You have to do 1/4, right?
Oh, you would put the x in the square root of parentheses.
So how would you have to write it?
4, x, no, wait.
It's got to have the same value.
4 and then 4 x.
But I want to still get this same yellow graph.
Oh.
Is that the same? Look at it. Don't look at it graphically. Look at it algebraically. Isn't that the same?
Yes, because you multiply.
Yes. Yes. All right. Let me give you a couple to do on your own. Let's see. I'm gonna give you 2.
Alright.
No, just give us one.
No, Luke, better give us two.
Dylan, why don't you stop?
Matt, they'll sit right here.
I really wanted to put these up side by side so you really could see the difference in the horizontal and the vertical. Okay. All right. So here, because it's in front,
It's a shrink.
he asked why. Okay. Shh, shh. It's in front. There's no parentheses. It's not hooked just to X, right?
So it's vertical.
So it's vertical. That's the key there to vertical. Whereas on over here, see how it's hooked just to X? It's horizontal. Okay, Avery, if it looked like this, that's horizontal.
Wait, but like,
It's hooked to the
What?
X.
Okay?
Okay, so if it's in the parentheses with it, it's
Correct,
horizontal.
correct.
Yeah.
Grouped with it some way.
Okay.
Okay. Now, remember this. Vertical is always what it looks like. Horizontal is always opposite, okay? So vertical, 2 is bigger than 1, dang. 2 is bigger than 1, so I'm going with stretch. And over here, horizontally, 1/3, because I'm horizontal, I'm backwards. So even though the A is getting small, it's a horizontal stretch. Okay? My factor here, vertical, is what it is, right? So my factor is 2. Horizontal,
his factor is 3.
the factor is 3 because I'm stretching, right?
But A is 1/3.
A is 1/3, that's correct.
How
Okay?
does it go?
To find the factor.
'Cause you would put
A is 1/3, A is 2. Okay, so look, yeah,
The horizontal was actually just
correct, correct.
So vertical A
All right.
is the factor, right? But horizontal A is
Flip factor.
flip.
All right. So on my little chart, this XY is gonna become, is gonna become.
X.
Are y'all laughing because I burped? I'm sorry.
X.
Okay, X and then
Oh,
2 times whatever that Y is. Okay, so every point on my graph, X will stay the same, and I double every Y. Okay? But when I get to this one, for every point here,
The X will times 3.
okay, all right, listen, because this is where it gets kind of confusing, okay? It says X over A, right?
Yeah.
Please stand for the.
All right, this is gonna
Thank you,
be,
Miss Young Evans. Seniors, it's time to vote for your senior superlatives. A ballot was sent to your school Gmail. Please cast your votes beginning today through Friday at 3 p.m. Friday, 3 p.m. is the cutoff. Senior superlatives will run in this year's yearbook, so make your vote count today. Also, please stop by the library to sign the senior signature sheets that will be printed in the yearbook as well. See Miss Horton or Miss McCauley to sign today. Don't forget, seniors, senior superlatives. The library ladies are sponsoring a Love to Read drawing this week. Students who check out books today, Thursday, and Friday have their names entered into drawings for Chick-fil-A gift cards. So, go by the library, check out that great book, and have chances to win gift cards. Don't forget. On Tuesday of next week, there will be an admissions counselor from Central Carolina in room 113 during lunch sharing information about Central Carolina student services, admissions, applications, scholarships, financial aid, and their TRIO program. In other words, everything you need to know about Central Carolina Technical College. Next Tuesday, room 113. Please go sign up with Miss Huff in room 113.